Hello again. In this video, I'm going to go over this homework problem from 2.3. And so in this problem, we're supposed to find the following limit, if it exists. Okay, so there's various ways you can find limits. You can create a table to find a limit. You can graph the function, graph this function here, and you could look at the graph to determine the limit. Or you can use the substitution method to find this limit. So I'm going to find this limit using the substitution method. Now remember, the way the substitution method works is we're going to plug in h equals 0 into this function to determine this limit. Now the reason I'm plugging in 0 for h is because h is getting closer to 0. Now remember, when you're evaluating this limit, what it's really asking you to do is to figure out what this is getting closer to, right? This function is getting closer to as h gets closer to 0. So technically, the limit is not asking you what's happening when h is 0. But nonetheless, when you use the substitution method, you actually plug 0 in for the h. And when you do that, you can see that you get 7/5 for this piece right here. And what that indicates is that as h is getting closer to 0, that this is going to get closer to 7/5. Closer and closer to 7/5. And so if you have a number here that's really close to 7/5, and then you subtract 7/5 from it, then you're getting a number that's getting closer and closer to 0 on top. And of course on the bottom, as h gets closer to 0, you can clearly see that the bottom is going to get closer to 0 as well. Of course, if you use substitution and plug 0 in, you would get 0 on the bottom. But again, that indicates, the way we interpret that is that that's an indication that the bottom is getting closer to 0 as h gets close to 0, which is obvious. Okay, so we're left with a situation where as h is heading towards 0, we're getting on the top something that's getting closer to 0 divided by something that's getting closer to 0 here on the bottom. And that's called an indeterminate form when that happens. So in other words, this particular form that we have for this function, when we try to use substitution, we end up getting an indeterminate form, meaning that we don't know what the limit is using substitution in the current form that it's in. And so in those situations, what you have to do is you have to rewrite the function so that it becomes a determinable form. And when you use substitution, that you actually get what the limit is. So it's determinable. Okay, so I'm going to manipulate this. So let's go through and manipulate this function to make it determinable. Okay, so what I'm going to do here to make this determinable is we're going to get a common denominator for this top piece here, the top part of this fraction. So notice the common denominator in this case would be 5 plus h times 5. Okay, so you're missing over here, you're missing a 5, a factor of 5. So I'm going to multiply this by 5 over 5. And I can do that because it's equal to 1. I'm not changing the value of it. I'm just changing the form. And then I'm going to multiply this one by 5 plus h over 5 plus h. Okay, now the reason I'm doing that is because this one is missing the 5 plus h. And again, this is equal to 1, so I'm not changing the value of this piece, this fraction 7/5. Okay, so having done that, you can see now that we have the same denominator and we can subtract the tops. Okay, so the common denominator is going to be 5 times 5 plus h. And on top of that, we're going to have 35, right? 7 times 5, 5 times 7. We're going to have 35 minus 7 times 5 plus h. Okay, and then and then all of that will be divided by this h here at the bottom. Okay, so then let's just clean this up a little bit. So we have 35 minus, and then I'm going to distribute this 7. So when you distribute the 7 to here, and actually this is a minus, I'm going to distribute this minus 7. So it becomes minus 35. And then minus 7 times h is minus 7h. And then that's all divided by the common denominator. And then that's divided by h. Okay, and then cleaning this up a little bit, you can see that the 35's cancel. 35 minus 35 is 0. And then 0 minus 7h leaves you with a minus 7h on top, all over that common denominator. And then that's divided by h. But I'm going to write this as h divided by 1. Now, h divided by 1, of course, is the same as h. But the reason I'm writing it that way is because we have a fraction divided by another fraction. And when you have something like that, you can flip the bottom fraction and multiply by it. So you flip and multiply in this case, right? So minus 7h over the common denominator. And then I'm going to flip this fraction so it becomes 1 over h, and then multiply by it. Okay? All right, and notice now these h's cancel. You have an h on top, which cancels with this h on the bottom, and that leaves you with a minus 7 on top. And then you're left with 5 times 5 plus h on the bottom. Okay, so what I've done is I've taken this original function, 7 divided by 5 plus h minus 7/5 divided by h, and I've rewritten it in a different form so that it now is minus 7 divided by 5 times 5 plus h. Now those are equal, right? The original function that we had is now, it's still equal to this negative 7 divided by 5 times 5 plus h. And so what I'm going to do now is I'm going to go back and find that limit. So we're going to find the limit as h goes to 0 for this new or this manipulated form of the original function. And whatever this limit is, it's the same as the original limit that we were trying to find, since those two functions are equal, right? I've just rewritten the original function in this different form here. Okay, now I'm going to use substitution again to try to evaluate this limit. So when I plug 0 in for h this time, notice on the bottom that you end up with 5 times 5, which is 25. And then on top, of course, you still have negative 7. And so that's the limit here. It's negative 7 over 25. Okay, so just kind of to recap this, the original limit that we were trying to find, when we used substitution, we found that we got 0 divided by 0, which is an indeterminate form. And that indicates that you have to rewrite the function in a different form so that when you use substitution, you actually either get a number out or you know that the limit doesn't exist. And so what I did to make this determinable was get a common denominator for the top fraction. And then that allowed me to combine the two under one denominator. And then that allowed me to flip and multiply. And then notice here that when the h's cancel, that's when it actually becomes determinable. Once I got those h's to cancel, it became determinable because you no longer are dividing by that h that you had originally. And that was part of the problem because h was heading towards 0. That h on the bottom was getting closer and closer to 0. And that h is the reason that this was indeterminate at first. So once you get that h to cancel on the bottom, then it should be determinable. And that's exactly what happened. Because now this final form that I had over here, when I plug 0 in for h, I no longer have a 0 on the bottom, right? I have 5 times 5, right? Which led to, getting the answer of -7 over 25. Okay, so I hope you found this video helpful, and I'll continue to do some more from Chapter 2, and hopefully you'll get a chance to look at some of those videos as well. Bye-bye.